Okay, it's already 4:35, so we need to start it without much delay. Okay, so first of all, hello. We are meeting after so long time, after a huge break because of our ESE. But now everything has done, and we are don't have any much work. So we have started to re continue our sessions. So anyone from you, do you remember what we have discussed in last lecture? In our earlier session about which device we have discussed. You can reply in chat box. You can hear me, right? Okay, I will tell you. In the last lecture, we have discussed about LDR, which is a light dependent resistance. And first of all, we saw what this LDR sensor actually is. Then we have discussed its internal structure, how it is composed of, how does it change its resistance with respect to change in incoming light or photons, let's say. Then we saw the circuit which is used with transistor, and which act as automatic light switching and day and night light system. Okay, we have also saw what the mistake we actually do while constructing voltage divider circuit, and uh, also solve that issue. Then at the last, we were about to discuss about an instrument called as a theremin, right? Do you remember about theremin? Hello, are you remembering? Okay, no problem. We have left that theremin incomplete because of time, but in the today's session, at last, we are also going to see that thing also, right? So the theme for today's session is transistors. Even though we are interested in learning automation using uh, Arduino and Raspberry Pi, but still many of the students have unknown about basic transistor applications. We got certain messages from some students. They were telling like how a transistor can be used, because we know that in the online scenario we are just taking help from internet and don't know much about designing and transistorized circuit, how a transistor is actually used for working as a switch, how does it amplify the signals. So those basic factors of related to transistor are standing behind. So to cover all those things, to know how transistor actually works and how application is going to be there. So suppose if anyone tell you that these are our requirements, I want to design a circuit with a fire alarm system, and I require minimum components, very minimum components, I need to design that circuit. So will you be able to design it without taking any help for internet? So because of for that, we need a clear understanding of how transistor actually works. So this is why we have chosen the topic for today's session, that is a fundamental of automation, which is transistor. So now I'm going to create a poll to know just your responses, whether you know about application of transistors or not. Don't worry, this poll is going to be absolutely unknown. It does not disclose your name, so you can respond what do you know. I'm just opening the poll. Just submit the poll. Yes, I'm receiving. Okay, just 3% are left to submit that poll. Otherwise, all have responded. Okay, there are just 2% still. Yes, okay. Yes, almost everyone has responded, and I got yes from two students and no from five students. I don't know their names. I just came to know that their number, and five students have responded. Not sure. So majority of students are not having a proper idea about how transistors actually work. How do they actually perform as a switch? Okay, so we are going to discuss. Hmm? Just let me share my screen. Okay, it is visible, right? Okay, we'll proceed. Hmm? So these are the pictures of transistor. How much in how much various packages they come with. They have various types and various roles, models with thousands of specification and whatnot. So they can and they are used everywhere. In any electronic circuit, there is at least one transistor is used because they are widely used. And we know that even our processors and the microprocessors like Arduino itself, they are while talking about a computer or its motherboard, there are billions of transistors which are wafered on a single silicon. It contains billions of FETs. It is not having any BJT. Just point to remember, every microprocessor has assigned FETs because FETs have scalable nature, so they can be reduced in size. And on a single silicon wafer, billions of such FETs can be mounted, can be fabricated. Okay, so these are the transistors. But we are now interested in two major types of transistor, which is a bipolar junction transistor and field effect transistor. So everyone must have idea about them. So there is nothing scope in interesting there what the BJT means, what FET means. We have coming seen it from long time. Okay, but the main part is for what two applications majoritarily BJTs have been used. They have been used for majority of two applications. Okay, first one is transistor as a switch, and another is transistor as an amplifier. As you can see in the waveform that the input waveform which has low amplitude and low voltage levels, it can be amplified up to higher voltage levels. Okay, so what property of transistor makes it a signal amplified, and also what makes it to act as a switch? So this is the main interest for today's lecture. Okay, so first of all, it comes to packaging of transistor. We can see, I will zoom in. There are two types of transistors mainly. We are discussing about BJTs, okay, bipolar junction transistor. First one is this, 1 minute. Okay, the first one is a resin case transistor. It is a small and low power transistor and used in general purpose like our 12-volt circuits, 9-volt circuits. And those high power transistors have been used in circuits with requirements of higher voltages. So what is the need of that metal plate? The metal plate in the small and low power transistor, there is just a resin case. But here, along with that case, there is a requirement of a metal case. It is because such high power transistors make huge amount of heat in power dissipation and such things. So these heat needs to be dissipated. Otherwise, the transistor won't work properly. And to dissipate those heat, such type of heat sink have been used. This transistor is attached with the heat sink with the help of any screw or such like material, and we can see here those two MOSFETs have been attached to a big heat sinks, and this is a picture of a power supply. Okay, so this is the purpose of using metal plate. Okay, so suppose consider a scenario. If we have to glow a bulb on a cell, then what we need to do? We need to obviously we need to turn on the switch. So when the switch will be turned on, bulb will glow. When the switch will be turned off, the bulb will off. Okay, on, off, on off, but it requires manual operations, because that means there must be someone who is turning on and on off that switch. So if we have to make it automatic, that's why we use a transistor. So in this circuit we replace a, this switch with a transistor. Okay, we have replaced this switch with the transistor. So now even if transistors emitter and collector terminal have been joined, but still transistor is blocking the current flow and hence the bulb is not glowing. So do you have any idea what changes in the circuit do we need to make so that bulb will glow? आपल्याला नेमकं काय करावं लागेल ह्याच्यामध्ये की ज्याच्यामुळे तो बल्ब ग्लो होईल? You can react in chat box. Okay, I will tell you. We need to attach, suppose if we attach a smaller voltage to its base terminal, if we attach a smaller voltage or a little voltage to base terminal separately, then the circuit will get completed and then bulb will glow. So this shows how the current actually flows through it. You just focus on the pointer, okay, laser pointer. In first case, I will explain how does it actually happen. In first case, we know the conventional current flow is from positive direction to negative direction. When there was a switch, the current was flowing directly. But in this transistorized circuit, the current will start flow from this and will reach to its collector terminal. Okay, no problem up to that. But the transistor is blocking the voltages. Transistor is not allowing current to flow through it. Okay, but when a small amount of current flows through the base terminal, then the transistor will open its switch. Therefore, the base voltage is necessary to act as open switch. Okay, and here now if they now there is a little voltage is applied to base, so we can apply a switch over here, and with the help of that switch we can again turn it off and on, right? But if we have to make it automized, we must give it external stimulus. So so we need to apply the sensors over here. Sensors are nothing but the transducers or the components which change its values or its resistance according to external stimulus. Okay, so if there is a thermistor, it will react to temperature. If there is a LDR, it will react to light. If there is gas sensor, it will react to gas leakages. That's all. Okay, so when there is sensors are embedded in circuit, it will automatically work. Okay. So how much base voltage is required to turn on that transistor? Typically, we need to apply about 0.6 to 0.8 volts to make the transistor on. Okay. These are just theoretical parts, but we are going to see and perform it this same procedure and same circuit in Proteus software. Okay. So it's the part of simulation. I am opening this Proteus software. Okay, before going with Proteus, just let me know in the chat box. Have you any doubt? Do anyone from you have any doubt on those things that we have discussed? Anything can be a question, and I would like to answer it. Also, we have the not only one people is hosting this meeting. We have the team of 5 technical members joining this meeting, so you can definitely tell us. We will try to solve your doubt. Do you have anything problem? Okay, no problem. Okay, if anyone don't have any problem, so we will proceed. Oh, sorry. Mistakenly, I have again reshared the same time. Okay, I hope you can see the Proteus screen. Hmm? We will create a new project. We are going from starting. I haven't made any circuit previously. We are going to perform the circuit here only. Okay. So first of all, we need to select the component. First is our power source. For taking power source, we have to type resource. We all have discussed those things in earlier session. So if you are not there in earlier session, I'm just once again repeating it. We select DC voltage source, then an animated LED. LED acts as an indicator circuit. And why animated? Animated LED have ability to react real time. Okay, so whenever there is change in current, it will detect us. I just like yellow color, so I'm selecting yellow color LED. Okay, then it comes to main part, which is a transistor. Okay, anyone from you reply in chat box, which transistor do we use? We also have seen this transistor in last time. It is called as a general purpose transistor. It is BC547 transistor. Okay. Okay. Hmm. We will mount those components. It is the power source, transistor, and LED. Hmm? Okay. Now we will attach ground because other because if there is no ground, it will not simply run. Hmm? And now we will add that voltage because it is just showing us something like 1 volt. So 1 volt is too less, right? So we will take as a 9 volt. Okay, if we run the circuit, you can see the LED is not at all glowing. Okay, LED is completely off here. So we will proceed to our next step. That as we have discussed sometime before, we will add a little voltage source in this terminal. Okay, so again I will select the source. I will connect it. Okay. So now just tell me what is that amplitude? 1 volt. But what we have seen sometimes before, we have seen that to on the transistor, we will require 0.6 or 0.8 volt to turn that circuit on. Okay. So we are going to verify those things. So first of all, we will select the amplitude as 0.5 volt and then run the circuit. So you can see that for 0.5 volt, again LED bulb is off. Hence, it shows that when the sensor is at free state, that is when it is not getting any stimulus from environment, then the circuit will act as open circuit. Okay, the current will not flow and hence indicators also won't glow. But when this voltage increases further, uh, when it reaches to 0.6, again LED is again not glowing. It has very less things. Okay, so okay, so to confirm those things whether it is really current is flowing or not, we will attach an voltmeter over there. Okay, so we will simply let know that is it really flowing or not. Hmm? Okay, there is, even though there is certain voltage drop, but still current is not flowing and it is not sufficient enough to turn on that LED, right? So we will again increase it. 0.6 to 0.7. Okay, now you can see that LED has just bright. Okay, it is just start blinking, but it is still very low. Its intensity is very low even at 0.7 volt. Okay, and you know that better, that 0.7 volt is the voltage of diode. Okay. Hmm? And now we will increase it furthermore from 0.7, 0.8. Yes, the LED has glown to its full level. It is the brightest one. Okay, and even if you increase it further, increase the voltage further, then it is still not going to increase. If you make it 0.12, let's say 1 volt, okay, then the brightness level will be the same, and you are going to get same 2.62 volt voltage over this LED bulb. Okay, so it is not going to increase. If it is 5 volt, again we are getting the same voltage. Okay, 2.81 something. So this means that to make the transistor circuit automatically on or off, the thing which matters the most is the base voltage. The base voltage, if it exceeds 0.7 volt or 0.8 volt, then the circuit will act as open circuit, and it is the sole purpose of using the sensors, because they will change its properties automatically in the circuit without any human interference. Okay, so that's why transistor are called as fundamentals of automation, and using this property only, the transistor are embedded in certain memory elements like logic gates, flip-flops, and comparators, amplifiers, and all those things. Okay, so here what the thing simply is happening in this case, in this simulation, we can see that while building the circuit, we have done trials with different voltages. Okay, and for 0.8 there was full. So what's happening is we are using small voltages and small currents to operate large voltages and current. Okay, if we put up ammeters in the circuit, 1 minute, uh, we will just see how much current is flowing through. Hmm? Okay, uh, also there is an ammeter. We need to rotate it because hmm? Okay, just 1 minute. The connections are same, but just it is reverted so that we can easily read those things. Okay, you can see that the base current is how much? 0.05 amperes, and the uh, collector current is how much? 0.20. So how much it is increased? It is 4 time increase. So this is nothing but the current gain, which is called as beta. We have learned that the current gain has formula of collector current upon base current, right? So this is called as a current gain, and that's why what is the happening in circuit is we are using very low voltage signal to make change in high voltage signal, right? And this is the property which is used in amplifiers as well. When we give an input of very low signal of magnitude, just like in milliamperes, it will be amplified up to certain voltages, right? Because of that current gain of different transistors. So this is the property which act in both in transistor as a switch itself and transistor as an amplifier also. So we will go back to our presentation again, right? Okay, have you got it? Have you got the circuit? Okay, we have gotten question like how sensors communicate with transistors. Okay, so just 1 minute. We saw this thing in presentation. I will reshare it. Okay, let us come to this slide. Okay, we are going to answer that question. Okay, we have seen that in this circuit, we can embed a sensor. Okay, the sensor is embedded and connected it to base terminals of transistor. Huh? Our question is how sensor interacts with transistor. So sensor changes its qualities, like it might change its resistance if it is resistive sensor. It also changes capacitance and also inductance depending on types of sensor. So when the sensor changes its physical properties, there is a flow of current in the circuit of happening. Suppose just like we have taken LDR at last time, when there is no light, the LDR has its highest resistance, and as the light goes on increasing, its resistance will decrease. So this property of sensors to change its qualities will generate an voltage. Okay, and according to this voltage only, the transistor is going to change its switching positions. Have you got it? These sensors can be simply connected to base terminal, or sometimes we need to connect it in a voltage divider circuit. We have saw voltage divider circuit last time. We are also going to see what the actual difference does it make, how it is different to use both the things. But this is how the sensor interact with transistors. Okay. Uh, Okay, so we have seen that how transistor act as a switch. What was happening in the circuit? I will repeat it once again. We are using small voltage and current level to operate large voltage and current values in the emitter circuit or in the main circuit. Okay, so we can use the same property for amplification. When we apply very low voltage signals in the base terminal, approximately in the range of millivolts, it will get amplified to certain volts. You can see here the amplified signal. It is the animation just made for illustration purpose. Okay, so this circuit is called as a controlling circuit, or this circuit is called as main circuit. Okay, and uh, and the easiest application we can make for amplification is microphone, right? Because microphone gives usually gives us low voltage signal values, and those signals will be amplified by speakers, right? So it is the very basic application of transistor amplifier, like audio amplification, right? Okay, so now we are going to discuss application of transistors. We have got certain about what switching actually means. Okay, so we are going to design the circuits. So first of all, we will design a circuit. Suppose we have given a problem statement. You need to that we have mentioned in starting. We have to design a circuit with for a fire alarm, right? We have to glow an LED or or ring and buzzer when there is fire in the circuit, and we have to use minimum components for it. Let me again open the Proteus. Okay. The Proteus, it is a circuit that we have made. Delete. Okay. Okay. So once again, we start our construction. V source, BC547 transistor. So to detect the fire sensor, fire has two of its qualities, right, one quality is its radiation. Fire is emitting infrared radiations, and another is its temperature. When there is fire, absolutely the temperature is going to be raised. So we are using thermistor. I think you might have performed this project in your PPL also, but we know what we were actually doing. We were just taking it from elsewhere and we're modifying it. So if it comes to designing by ourselves, this is how we can proceed to design it. Okay. Now we need to take um, thermistor. we can select first one. Okay. Then we will select an potentiometer. I have mentioned it last time. While selecting potentiometer, you must select pot HG, because pot HG is meaning high granularity potentiometer which has interactivity. Whenever there is written active, it means we can interact with those components. We will place an potentiometer. What basic things we have discussed? There is sensor, there is base current, and there is an indicator circuit. So for indication, I am again selecting yellow color LED. You can take any color. Okay. Okay. Let's go stepwise. Let's connect this LED to its emitter, sorry, collector, and emitter to okay. It is again this and I will increase its value 9 volt. Okay, again the circuit is not going to run, right? Because there is nothing connected to base. So what we have to do, we have to connect that sensor so that the current will also flow through base terminal. And what much we want? We want only up to 0.7 or 0.8. So we are going to connect it to that thermistor and also here. Okay. Okay. So now tell me, what is the normal room temperature and what temperature can be considered as a fire? Reply in chat box. It's just a common question. It is not any technical question. How much temperature is considered as 40 degree? We are going to design the circuit accordingly, right? So it is necessary that you should reply because we must know that up to what temperature it is required. Okay, anyone have any idea? Okay, we again got one question that how thermistor, what that question? How thermistor relates with fire alarm. Okay, so we know that fire alarm, I just like I have told sometimes before, fire has its two characteristics. Okay, one characteristic is its temperature and another characteristic is IR radiation, that is infrared radiations. Okay, so both those characteristics caught by the sensor will can be considered as a fire. So thermistor is a resistor which varies with its temperature. Okay, so if there is change in temperature surrounding the thermistor, then its resistance will decrease. If we see at its graph, as temperature will increase, the resistance of thermistor will decrease. Okay, so when there is rise in temperature because of fire, then the thermistor resistance will keep on decreasing, and as soon as the resistance will decrease, the base terminal voltage will be start flowing. Okay, so this is how thermistor relates with fire alarm. Thermistor is used for changes in temperature. Okay, we will select as a normal room temperature for 40 volts, and the 50 volts or more than 50 volts can be considered as a condition of fire. Okay, so I need to make some changes. I will change temperature steps as 5 because it will be easier for just adjusting those levels. And what is the value of this potentiometer? It is 1K. 1K is very low range. Okay, so we will consider it as 50K. Why 50K? It is as it is a voltage divider circuit. We saw it last time. In voltage divider circuit, the higher will be the R2, higher will be the voltage. Okay, so that's why we are selecting high volt potentiometer. We have an choice of adjusting the resistance. Okay, So first of all, okay, there is no ground. You can see that for 25 volt itself, the LED is glowing. That means that our fire alarm circuit is totally going to be failed. It will just ring all the times. It will never stop. Okay, so we need to adjust its resistance accordingly, right? We will increase its resistance furthermore. It is still happening like this. You can see that even if we are increasing it increasing a very lower values, the circuit is going to be like this. Okay, so we have done again something wrong in this circuit. So it's your time to spot out the mistakes, just like last time. See, I am here varying here, I'm continuously varying here those levels, but the bulb is always on and we need to glow that bulb over 50 only, so it is not going to work again. Okay, so what we will do, we will just add a resistor. As no one is replying, I need to answer all those questions again. Okay, for resistor we need to type min res, and let's select its value as 10k, because we saw that the large amount of current is already flowing through the base terminal, and we want the range only related to 0.7 or 8 volt. Okay, so that's why to limit it further, to limit it furthermore, we are applying here 10k resistor. Hello. So you have seen that the circuit is still not changing, right? So there is again anything wrong. So we have received a message that meeting will going to end in 5 minutes. So I will tell you the mistake. We again need to add that potentiometer in upward level and add that thermistor in lower level, because the R2 will be going to be greater, and that's when only the circuit is going to work. Okay. Now we will proceed further. We have decided to see the circuit of theremin. Okay, you can see that the images. Okay, the images of theremin. We have discussed this instrument last time. There are two antennas protruding, like you can see in this image. That girl was moving his hand, and have you seen the pictures like Avengers and End Games? They are making any sounds of background themes or war times. So all those sounds are made using this instrument. When the artist move his hands, the changes in electromagnetic fields or interruptions in it will produce an changes in output of sound. So we can build the same circuit using LDR sensor that we were discussing. Now we are going to implement this circuit. uh, actually I thought it to implement by us only, because it will clear all those things in construction, but we again have less time, so we will just go with that already implemented circuit. uh, See here, this is an LDR sensor which is connected with voltage divider and connected to A0 pin, that is an input pin. Okay, then at the output pin we have connected a capacitor of 100 of 1000 microfarad, and here we have given a resistor of 100 volt, sorry, 100 ohm, and then here the LED, and this is our transistor. Okay, this transistor is selected because of its gain, reactance with its current gain, so that's why we have selected this instead of using general purpose. So when I run this circuit, you can see that the LED bulb is fluctuating. Okay, take 1 minute. Uh, I will select its values. Okay, you can see that that LED is blinking, right? As the temperature is increasing, or as the LDR signal is increasing, that LED is going to fluctuate. See, you can see that. Can you see? Why we have implemented LED? Because buzzer, we are not going to hear any sound from buzzer in this simulation. So to make it understandable, we are using here LED because it will indicate us. So as soon as we are changing the light, focus on this mouse cursor, as we are changing its LDR's value according to right, then simultaneously the LED is going to blink. So what we are actually doing, we are putting our hand over that LDR sensor. The closer we get our hand to LDR, the higher will be its resistance, and similarly when it get light, lower will be resistance. So these values in these changes in resistance is going to change the values, and that's why we are getting here deviations of LED bulb. So this is how theremin is going to